This is a problem about the vertical motion model or the projectile motion type problem. These are application problems of quadratics. So the height, when we're talking about, let's see, in this situation, you can see the problem up here. The height of an arrow shot into the air can be represented by this equation. So they're giving you the equation where t is time in seconds and h is height in feet. Okay, so they've given you this. What you're going to do is come over to Desmos and type that in. But instead of using, you can see instead of using the h and the t, I used x and y in here. And now I have the quadratic is represented, the parabola is over here on the graph. So I'm going to think logically about this and figure out what information I can get. Usually you're looking at the vertex and the zeros out of this picture here. So what is the maximum height of the arrow? So that arrow is shot up into the air. Oh, that's why. Okay, it's shot up into the air and then it starts coming down. So if I'm over here looking at this parabola, the maximum height is going to be right here at the vertex. And remember that time is on the x-axis and height is on the y-axis. So we've got, here's our picture of what's happening. This is time and this is height. And this arrow is shot up. It looks like it's shot up from about 6 feet. So maybe this person's about 6 feet tall. And they shoot that arrow up in the sky. It comes straight down, right? So that's the max height. And that is a x comma y coordinate. The x would pertain to the time it took to get there. The y is the height. So if I come over here and just click on the vertex, Desmos is telling me what that height is. So 195.063. Okay, so what is the maximum height of the arrow? 195.063. And we would say feet, right? Because it told us the height was in feet. Okay, and you might want to round that. I don't know. Didn't ask me to. How long will it take the arrow to return to the ground? Well, it returns to the ground when it's down here. And then how long talks about time, right? So I'm looking at the x value of this point right there. So if I come over here, I'm going to look. Got to go down here. That's where it's hitting the ground again. And that was 6.929 seconds. So 6.929, and again, maybe you want to round that. And seconds, because it told me the time was in seconds. Now here's where the problem gets a little more tricky. What if it asks you a question? So this is different than what's printed here. At what height is the arrow after 3 seconds? After 3 seconds. Or even after 2 seconds. They could ask us any number. What we're going to do is we're going to plug in. So seconds is a time, right? And you have this equation here. So you could substitute this in if you want to know about 3 seconds. So then everywhere there's a t, I'm going to put a 3. Negative 16, 3 squared plus 110 times 3 plus 6. And then I do this math. And what does it give me? It gives me the height. It gives me the height when the time was 3 seconds. Well, there's another way to do that, which is to use a table on Desmos. So I come up here and I'm going to use a table. And I want to know about when x, or t, right, because they're the same thing, is 3. So I'm just going to come down here. I can either click to go to one more. There you go. 192 feet. When the time was 3 seconds, the arrow was at 192 feet. What about at 2 seconds? At 2 seconds, it was 162. What about 4 seconds? Okay, so this is seconds, right? This is the amount of time, and then this is the height that it was. So that's how you can use Desmos to answer your question.